Okay, thanks for coming. I'm going to introduce myself properly, but let's just mention first that what's the topic here. This talk is about designing and deploying a full semester Clojure course. So I will talk about how to teach and how not to teach Clojure to beginners, and in more general, the cognitive difficulties of problem solving, and also my personal mission of trying to understand why I like this language. So I will introduce myself, and I of course will give a background story how this happened, and I will talk about the design of the course, then of course running the course, and probably what's most useful for you, I will talk about general problem solving and coding insights, and talk about the future of the course as well. So, who am I? Well, I'm a software engineer disguised as a mathematician, and I work in applied computational abstract algebra. Well, don't bother looking it up. I made this up completely, but that's the best description of what I'm doing. And I also teach traditional math classes. But probably more interesting here, my language history. I started with Commodore 64. I did assembly in manually, just putting the numbers in. And then, of course, at university, Pascal and C. Then, as a software engineer, I worked with Java. Then I left industry, and I did academic research using the GAP system, which is really great if you do group theory, and it's sort of hybrid, functional, object-oriented. And then I use Clojure for recomputing these results as for just gathering evidence. Okay, this is the place where I come from. It's Akita International University. It's a very small liberal arts college in northern Japan, but with the specialty that all courses are taught in English. This will be quite crucial for what I'm saying. And we also offer programming courses, C# and Clojure. And you might ask, how come? Well, what's the rationale for teaching programming? Well, you know, there is a hype around this, and that's why we should teach everyone coding, including kids, which is, I like the idea, I just don't like kids hunching over laptops. So it's, let's say, it's a slightly controversial issue, but what we can agree about is that every university student, regardless of the major, should have at least one good programming course, because it's just part of universal knowledge. In particular, at AIU, we are working on a new major called Digital Studies, which you might think of as liberal arts, sort of getting a digital upgrade. Well, that was the official rationale. How did it really happen? Well, I landed in a new job, and I realized that there was expectation for deploying new courses. And of course, if you are an academic, this is an extremely great opportunity, because you can design your course and you can teach what you like. So first I did, just a discrete mathematics course about basically explaining how computers work, and that's I like that part of mathematics. And then I realized that, the expectation is still on, so I needed to do more courses. And of course, I had to come up with a new tactic. It's like, okay, let's suggest something which is crazy enough that it might get rejected. So I get more research time, or I get a course which is research itself. So this is how this poetry of programming came about. Okay, at this point you might ask, poetry? And well, of course, in a limited sense. If you think in terms of a haiku, it's a very short poem focusing on a feeling or a situation, but it's a very expressive use of language. Well, that's exactly what I plan to teach, expressing an idea how to do something or describing a problem with a very short but very expressive piece of text. But of course, the question was that would the students come? Okay, you can see I tried my best in marketing the course, and actually they did come. So 16 registered and 14 finished the course, and the gender ratio is 3:11. You might guess which way it is, but it's not 0 to something. So that was great. Okay, well, I had to design the course. And first, you want to do it in the easy way, thinking that, oh, there are very good beginner books. I just walk into the classroom and start teaching those. But then you realize that these two very great books, they are not for the complete beginners. They target software developers who want to learn Clojure. So my audience is just different. So I had to think about this problem, how to teach beginners. And I realized that I had to do three things. I had to find shared background knowledge in order to ground the metaphors. And of course, I had to produce some very focused material, minimize the amount, and one concept at a time. In particular, for our students, the shared background knowledge is actually high school algebra. And well, in Japan, you get quite good high school algebra background, so real-valued functions and even some bit of calculus is known. And it's very important that all the students there, they already learned one foreign language, like mostly Japanese, and they are learning in English. Regarding the reduced material, of course, I cannot teach any tooling, no ID, no Emacs, just a repo. And of course, the same argument is like no Java interop, because that's another language. So that leaves the functional core of Clojure. And well, I started thinking that, okay, that's what I want to teach, but how exactly and in what order? So I figured that, well, I have to do it one step at a time. That means that I want to introduce a new concept when all the parts are already known. So for example, you might think that, well, function definition, that's where we start, right? That's the easiest thing. But if you think about it, it's not quite, because it already has many things. Of course, well, you have to know about lists and function calls, but you have to explain what def does, and you need vectors for the argument. So it is not as fundamental as it seems. And well, the alternative is to ask for postponing understanding. You say that, well, okay, you need to write this, but you don't need to worry about it now. Just well, you remember hello word in Java. So my question was that which path in this dependency graph of Clojure functions and concept maximizes speed and fun? And it's not an easy and not a simple question, because some of these students, they will probably just have this one course exposure to programming. So you want to maximize the fun. Okay, so running the course. Well, I found my starting point, and it might be a bit peculiar. It's function composition. And the reason is because I teach it. I teach it in college algebra, and I taught it many times. And I said that, oh, okay, when you do function composition, basically you are already doing programming. Okay, just trying to improve the stance of mathematics, saying that, well, this is useful knowledge. So well, the obvious next step is just to do it. And the argument goes that, well, if you had to learn this stuff anyway, why not using it? All you need to do is just to move the parentheses a bit, and you get exactly the function composition. Okay. Starting with simple functions, the identity is the most important simple function, and of course just doing a bit of arithmetic. And then the game is on. It's like, so what can you do with a limited set of functions? Okay, you want to start something, a very small set of functions. Well, I had to sit down and think about how to put these together. So, well, this is sort of a koans style game. So what's the value? If you compose increment with decrement, or of course that's an identity for numbers. But here's another little puzzle. It's what happens when you compose with itself. Okay, then it's like you have to think about, does it make sense when you have compose without any argument? And of course it does make sense, because that's the identity function, because it has to compose nicely, and you have to give a nice default values for composition. So basically, composing with compose is just compose. So this will be -1. But the point is that this forced me to revisit these functions. So I had to think about it, I had to look at them again. And here's the question in red for everyone. So when do we stop learning? Okay? We start learning the language and we admit that we are beginners. But once you get comfortable with it, oh, you know, I can code in this language. Well, I mean, we just stop, right? We don't look anymore unless there is a problem. So it's useful then, you know, to look at the well-known stuff again and again, and you discover interesting things. And actually, this turned into the way of how to do assessment. Actually, students asked for this. I was a bit late with that because, well, okay, we are having fun, but there is an expectation that, well, there has to be a grade at the end, and it's not just administration, but students themselves. And, well, how do you do a paper-based exam, right, in a programming language? And actually, you can do it, right? It's this reading exercise. I did a lot. So here's a one-liner, what's the value? And it's coming out of it. And of course, I didn't require them to write down the exception. It was enough to say just an error. And well, regarding exception, I told them that, well, when you get an exception, well, you just think about the problem more and start again, because it's probably easier. It's for small problems, you don't need to figure out what happened in the error. And some students said that, well, okay, this was a really great way for learning the language. Okay, and also function definitions are not urgent, because many data structures, they behave like functions. Well, you can have this silly exercise, you can compose vectors with maps, but actually it's not that silly, because if you look at it, well, there is a more sensible one. You can map the digits to the English words, and it's again just a function. Another non-issue, immutability is not an issue. Right? I can do this little piece of code, and if you're not surprised that 4 does not appear in vector v, then just no worries, we can move on. And it's, you know, I went through from Commodore 64 assembly to Clojure, but they don't have to go through the same path, okay? That's an enormous opportunity. And it's a nice experiment to see new generations of programmers starting with immutability straight. Okay, I was very happy to have the conceptual or cognitive metaphors coming into the Clojure community, so I can refer to them. Because that's what we do in teaching. We need to find the right metaphors. For example, for binding values, it's like creating long-term memories or attaching meaning to words, and both hint towards immutability. And of course, we got to the part when we define functions, and there's just the usual algebraic abstractions. You do a couple of calculations, you identify the moving part, and so you put a hole into the expression for that part, that's your x, and you can do this abstraction. Then you give it a name and you use it everywhere, okay? And this seemed easy and it worked well, and at this point my vanity kicked in. It's like, okay, what did I do in the last 20 years if students can learn this fast, right? So, but I mean, this is how people are, they think this way. But it was not that easy, because the next corner you hit a roadblock, and you realize that, well, we established the shared background knowledge, and that's mathematical functions. But when we leave that, well, that's new for them. So when I just told them to write a function that somehow mixes strings and numbers, and they were like, okay, what happened here? So it's actually the same problem as in mathematics. That we sort of stop when we have to work with objects that are not familiar. Okay, So I thought, well, I had to put a bit more efforts on bridging this abstract realm and the everyday experience. So, well, since the reducers talk, we know that it's apples all the way down anyway. So I introduced a bit more fruits. And so the key point here is that the concrete example, as like separating the oranges from the fruits, and the abstract example of the same idea, we use filtering a collection. It's just next to each other. And of course, Clojure's list syntax is quite nice. It almost reads like English text. And well, visualization is always helpful. What makes filter great? Well, because we have these truthy and falsy values, and it's very flexible. We can filter by set. So, well, created this diagram to emphasize that we can treat almost everything as true. Okay, map. That's we just repeat the same operation for all elements of a collection. We'll peel the oranges, and this was a general advice I had to give the students all the time. That well, all you have to do is just to figure out how you deal with a single element, because collection processing is automated. And it's strange enough, even students with no previous programming background, they sort of try to do it. It's like, okay, I understand map, but I still have to go through the collection somehow. Okay, so it's an interesting fact. And yeah, I mean, you should try this game, maybe not now, but I think this game can teach you functional programming in a very entertaining way. And then, yeah, I introduced reduce as well. And, well, again, the concrete, the fruit salad next to the reduced collection, abstract and the concrete example together. But I need to talk about reduce a bit more. We have nice metaphors available. You know, that's the child is on the beach and collecting the pebbles in a bucket, or just looking for the most beautiful pebble. But what I found is that the most useful thing is the reductions function. It's like a built-in debugger for reduce, right? And it shows you exactly what is happening in the reduction process. Okay, so, well, this is the point where I had to actually reconsider my way of thinking as a programmer. Naturally, we play this game of reimplementing functions that we use just to understand how they work. And I started with the recursive implementation. Then later I introduced the one with reduce. And the question is, which one is nicer? Which one is better? And of course, in what sense is it better? And well, in terms of cognitive load, well, the reduce one is a lot easier, because for the recursive one, you have to imagine this hanging cons calls on the stack, right? And if you don't have the background knowledge of the stack, then it's like, well, you don't even know what to imagine exactly. So what I found that I was blinding by recursion. That's my sort of academic upbringing. You know, self-reference is the thing when it starts becoming interesting. And of course, well, it's a cinema experience as well. So it's like recursion is great. But I have to think next time I will do reduce first. Talking about the schedule, so here is what I did in 15 weeks. It's like 2 classes per week. So that totals in 37.5 hours. And so this is the weekly schedule of it. As you can see, I did quill the graphics at the 14th week. Okay, I did not introduce mutable functions. I didn't even introduce print line, because you don't need. It's in the REPL, it's already printed. And as you can see, I did recursion first and then reduce later, which I will do the other way around next time. So, A few words about the class format. Well, most of the time it's like I did a little bit of live coding. It's instead of lecturing, using my Raspberry Pi and the Emacs and Cider. And the good thing about live coding is that, well, of course, you don't just want to go straight to the solution. You sort of want to dramatize it. So first you do a couple of false attempts. But if the problem gets just a little bit more complicated, and it's very easy, you know, just map get on the wrong level in the recursive call and you get something completely different. And it's not acted anymore, it's real. And I'm wondering whether the students realized that it actually happened in the class, that I didn't really know at the spot how to fix the problem. But okay, that's live coding, and 2/3 of the class is problem solving. So they actually solve these little mathematical puzzles I will talk about. And I did what I call patrolling, just walking around and looking for screens with the most read text on it. And the great thing that happened, the students helped each other. Okay, so one student finished, stood up and went and helped other students. I mean, that's really great. So an example problem is the Collatz conjecture. It's a very nice puzzle. You have this function defined, and it's still an open question in mathematics, but it is conjecture that no matter what x you put into this function and you keep iterating it, eventually you get back to 1. So the question was, what number between 1 and 1,000 produces the longest sequence? And well, it's an easy exercise to define the function itself. Then, well, you need to know a bit of collection processing and lazy evaluation, and so you can find the sequence length of that. And then it's basically, again, just collection processing. You have to find the longest one. And this one, actually, the solution came out quite nice, because it happens that the longest sequence is 178. And which one is the number that produces that? Well, that's 871. And students were happy. I was like, wow, okay, that's a very nice exercise. How did you design it? And it was just completely a random choice. Okay, but what I wanted to talk about here, that most concepts I try to introduce as code transformation. So that means that we already have a solution, but I show that, oh, okay, if you write it like this, then it's, well, nicer, simpler, or better in a way. So for example, in this particular case, I introduce max key, and it's just one line instead of 2. Except that apply seems to be a pain point for some reasons. Even, I mean, you know, I thought I used very nice metaphors. It's like, well, this container data structure is just packaging, and you cannot eat the apple if it's in a package. But it's especially confusing. Well, addition is a very nice case, so it's apply and reduce seems to be doing the same thing. And I also vaguely remember that I had a slight problem with apply, but I don't remember what was exactly when I learned Clojure. So I still don't have a clear answer that why apply seems to be a difficult one. Okay, so here's an example of a complicated solution. Because often they come up with a very complicated solution, and it's like you think that it's a lot more difficult to do it that way. Okay, so here's one. As from the very beginning, you have to write a function that multiplies a number by 10, and the solution by the student was this. And I had to look at it as like, okay, what happened here exactly? So then I realized that, oh, okay, I see what happened. So I told the student that it can be simplified this way. Well, as the student was like, really? Checked in the REPL, yes, but then I don't understand. Okay. So, I mean, this is the type of problem you get, and I had to think hard that, okay, so what to say in this particular case. And of course, what's happening here, that maybe there was a half solution without the definition of just using the lambda function, then it got put together. So what happens all the time that you have some half solution or some dead end, and the students keep it, and that changes the problem. And then when they finally put together, it has a whole history of problem solving. So yeah, at this point, I had to think about problem solving again. And here is the book. And here everyone knows this book because 5 years ago, Rich told you to buy it immediately after his talk. Okay, so I can rely on this fact that this book is well known. And luckily, it is a book about heuristics in mathematical problem solving. And most ideas translate quite easily, especially for this scenario when I use a functional programming language to solve little sort of mathematical puzzles. So, well, yeah, in the process of the semester, I produced this document. I will give the link later, and I even try to reproduce the typography of the old book. But of course, the actual advices are specially suited for this new functional programming. Okay, so just to remind you what are the steps of problem solving. First, you have to understand, well, that's a no-brainer. You can't really write code if you don't know what you want to solve. But making a plan, that's slightly different for in this situation. I told the students many times that you just play in the REPL. Then I realized that actually it's probably not clear what I mean by playing in the REPL. Okay, so then I clarified that, once you identify the problem, you know the type of your input and you know the type of your output. And if you don't know how to start, well, just try a few functions you remember about dealing with this type of data. And then, it's just mobilizing information, mobilizing knowledge. Okay, and well, once you know what to do, you just carry out the plan, and there is a loop of writing, testing. And it's most important looking back, because that's an instinct. The correct answer appears on the screen, and the student is, okay, solved. We can move on. And it's, no, it's like, that's where learning starts. When you have the solution, now you can look at it, how you did that, and you can think about it more. Okay, but this was one of the failure points. It's like playing in the REPL. And I had to think about it, and well, I listened to other professionals, how they use it. And it seems that, okay, so once you have the REPL and the editor, the beginner's workflow is different compared to the professional one. The beginner, they try to figure out the solution in the REPL, and then, there's something useful, they copy it to the editor just to keep it. While the professional, as you know where you are heading, you just want to check whether your candidate solution for a particular problem is good or not. So here's what happened. First, we just started with the REPL. This was a choice by students, probably nice colors, and of course the available documentation, and we used it happily for a couple of weeks. Then I realized that the students started copying the solutions into, well, a word processor, which is probably the worst thing that could happen to a piece of code, because it's like looks very bad. But okay, so but luckily, just slightly before that, repl.it came up with a Clojure support, and I thought that, okay, this is great. This is what we need here, because well, they can save their solutions, and they can send it to me, and they can bring it as a homework assignment. And it looked good, except that what I saw that the students immediately gave up the REPL. Okay, they went to the editor, and I had to tell them many times that, look, you can't do it, we can't do it. It's like just writing the code and figuring out the solution without checking the pieces. It's very difficult. So I always said that, well, try it in the REPL, try it in the REPL. And one thing is that probably it was due to the interface a little bit, is that they just have a single button for evaluating everything. Okay, so it's not like that you put pieces there. And well, that caused a bit of trouble as well. And well, that's probably due to the reason that repl.it supports many languages, not just Clojure. Okay, a few words about the documentation. Well, you know, the inline documentation is great, but it's probably geared towards professionals. And students use Clojure docs quite a lot, and it's very useful, but simple and advanced examples there, they are just totally mixed in no particular order, and that caused a bit of problem. And well, the weird character guide that came out, well, it was posted on clojure.org, and the students cheered it. It's like, wow, that's totally awesome. Unfortunately, we have to deal with the Stack Overflow effect, and so that means that the students just searches it, finds the solution, and copies it there. And that's okay. I mean, we do this all the time. But in the learning setup, this is really not what we want, because it leads to solutions but not understanding. Okay, so it's like typical case. Student shows, well, here's the solution, and it's like, wow, okay, well, you are using these threading macros. And of course, I haven't mentioned threading macros yet, and so there's no real understanding. But okay, another thing, which is still after solving the problem, you want to go back and think about your solution, because we don't just, most of the time, we don't just have a single solution. We have several different solutions. So it's better to think of it as a solution space rather than just a single path. And this was actually a solution for the absolute value problem. And I was glad to see two different solutions. Of course, if you think about it, these two solutions are not different because, well, they do exactly the same thing. It's, well, of course, it depends how you define being a different solution. Okay, I need to talk about what to do in the future, and well, the course will be offered next winter and next spring semester, so it's an ongoing story, and I'm thinking a lot how to improve the course. Well, one thing is that, well, I have to go from reactive to proactive in a sense that, well, when I started this, I was convinced that the functional core of Clojure is the ultimate beginner language, okay? But that was just my thinking, so you know, I could have gotten wrong. But after the one course, I can say that, well, yeah, this is really great for beginners, and they can get very far in problem solving with very little. But of course, now I know the pain points, and I can do it more proactively addressing those. And what I normally do in other classes, that I have a summit of the course. It's like saying that, okay, we are heading there. And in algebra, that's Euler's equation, because it's just so crazy looking. And in calculus, it's the fundamental theorem of calculus, which is, again, surprising. Just integration is inverse derivation. And I think in Lisp Clojure settings, that would be the metacircular evaluator. And that's probably, it's very nice in the liberal arts environment as well, because it's sort of a meta-linguistic abstraction. So I will aim to do that. Regarding tooling, now I think that I will try night code and parinfer. So I didn't say anything about managing parentheses in the previous course, and of course, eventually it becomes a problem. So now I think that I will try to address that up front. Okay, so the summary, the question is, what is achievable in one semester? And well, I can say that, well, map, filter, and reduce, and the persistent data structures. And that's a whole lot. So you can do many things with that. And also, well, here are the suggestions, and that's not just for students and teachers, but it's basically for everyone. The learning process basically never finishes, right? So it's a good idea to maintain a beginner mindset. You can always have a fresh look at the function you use all the time. And probably the best way to do that is that if you could expose yourself to beginner thinking by teaching, then you should consider yourself very lucky, because that helps you a lot. And again, metacognition, thinking about your coding, the way you code, that of course improves your coding. And then the last idea, think of a solution space, not just a single solution. This scales. It's not just for little mathematical problems. It scales through the big system. You need to consider alternatives for that. Okay, and for my personal mission, well, I mean, I still don't know why I like Clojure that much, but I can say that your love of Clojure cannot be destroyed by deconstruction, by trying to look at the pieces and breaking it up into little ones, and you still like the language. And here's the link for the course material. It's of course being developed, and you can, if you are interested only the how to code it part, the heuristics part, that's there as well. And thank you very much. I mean, well, I'm happy to take questions if there is any. Yeah, sure. Out of 14, I had 3, and one came immediately and said that, oh yeah, I'm doing my work in Scala and then thinking, it's like, oh, well, this is great, except that this will be slightly different. And then came the second time and said that, oh, why are we learning this primitive language? And okay, it's like, what do you mean by primitive? Well, that doesn't even have a for loop. Okay, and it's like at that point, you know, thinking of the dependency graph, the least comprehension went in the very end. I didn't want to argue about that, and so yeah, it's more difficult. And unfortunately, well, I found it a bit sort of sad to see young people. It's already having very rigid thinking. I like the persistent data structures, and I like hash map and hash set and how it's used. So I don't know scheme that much, but I think I would have a bit of problem giving that up. Yeah. Yeah, liberal arts college and non-computer science. I would change a little. I would just double check their math background, because they might not have, you know, function composition. But it wouldn't change a lot. Yeah. Oh, sure. Yeah. I mean, that's when I want to go from reactive to proactive. Now I know it's a pain point. I think about it. I will try to find the best example. So yeah. You mean the foreclosure? Yeah. Sure, that was the starting point. Initially, I thought the assessment would be that students just come into the class and it's just, okay, let's see how far you get on foreclosure. But again, a foreclosure also has problems that relies on other background knowledge, so I couldn't do that. But yeah, sure, that was inspiration. Sure, it's done by the university. So, I mean, the actual numbers are probably not telling that much, but it's more the feedback than what needs to be done. It's like, was it fast or was it slow? And you know, I still get in the end of the course that it's like, well, why not learning something more useful like Python? Okay, and it's like, oh, okay, maybe I have to rethink how good I was in delivering the message, why this is cool. So. Yep.
So at the beginning you mentioned that there were at least two pieces of shared content, right? They had physical algebra, they also had learning of foreign language. Do you find that is the shared learning of foreign language at all?
Using the foreign language, yeah, I leaned on that metaphor a lot. As for example, when I define deaf, that's basically sort of like, I mean, whenever you want to understand a piece of code, it's like reading a text. You want to figure out what's the meaning of each symbol, right? And so that's what I said. It's like when you learn a foreign language, you need to know what the actual meaning of a word is and what's the grammatical structure carries as meaning. And actually, I do the same with mathematics. I'm telling them that, well, if you learn a foreign language, then you already did a lot harder task than learning mathematics, because while in mathematics and programming languages, they are designed to have a single meaning, and they have to be well defined, and you don't have that in a natural language. And the students, like, well, they say that, well, math is still difficult. So that's the argument. Yeah, I use that a lot as a metaphor. Well, thank you very much again.